Hello everyone, welcome to a tutorial video of how to model Sikla parts within AutoCAD. For this we'll be using the Part Solutions Catalogue by CADENAS, which can be downloaded in a couple of ways. If you are from the UK, you can search the sikla.co.uk website within our download section. At the bottom of this section, we have a planning software tools area, and you can use this link to download the software that we're going to use. If you're anywhere else in the world, or you are listening to this in a couple of months' time, the Sikla.com website will be running live across the world, and the software can be found within the download section, and we just use this navigation tool to change the category to software, and it can be retrieved in a very similar way. So this is about 1.5 gigabytes, this install, and what this is a large catalogue of all the Sikla parts. We will download this, if you haven't already, onto your desktop or C drive somewhere where you have space, because what happens is every time you use the interface, a copy of the parameters are made into another area of your choice on your machine. So this can be run online as well as offline. There are some advantages to running it online, like parts updates, but an advantage of downloading this is that this can be run offline if need be. So the version of the tool I am using is version 12. And when you do copy and download this file, you'll extract the file somewhere, as I say, onto your machine. And within the zip file is a CD start or execution file. And what this does, it just points to the directory there where you've installed and looks at the parts that you have also downloaded. But to use these parts, we will execute the file using something like this button here. I've just copied it onto my desktop for the time being. And when I double click that file, I have this splash, introduced to this splash. And what we want to do is click Sikla Library to run the tool. Give it a moment, and we will have the CADENAS Part Data Manager interface. Now there is a number of ways to navigate around this tool. I will show you the most popular. You may think that the search and part selection interface here is the easiest way to do this. Some people do this, and it is essentially a mimic of the Sikla product catalog. So we have different product ranges, okay? But what I have found over the years of this process, and I think others would agree, is to search using this toolbar here. So you can fill this with shortcodes for Sikla part names. So if you're familiar with the Sikla parts already, that is an STA, a WBD, TKO, for example, or specific Sikla part numbers. Let's use that as an example. We have a N support WBD, a 192801 as an example. And what that's done is filtered all the parts just for this one item. If we double click, then we have narrowed down some of the data. Okay, and as this part is within a category of N supports, you can see we have a filter active because we searched specifically for that part number. We can deselect if we need to see all the types of similar items within that range. And the graphical interface down here reflects the part that we are currently selected. If we were to choose another part, we see a pretty graphical image of the item you're selecting. Now this is quite a useful, nifty little tool because you can view this item as if it were in real life, in situ. We can zoom in and out. We can, with ease, right-click to bring up this tool and measure if you needed to find a specific characteristic of this item. So let's say I just want to know the thickness with ease. I'll click this plane, rotate the item with my left mouse button and click the back of the item. So we see we have 12mm thick. Plane to plane is 12mm thick. There's lots of different types of measurements you can take within this tool. If you delete, we can go again. Let's just say we want to know the radius of this end of the slot. So we have a radius of 7mm, for example. Okay. Lots of different measurements that can be made. And I'm just manipulating this using holding my left mouse button. Okay. We also have the ability to look at this in greater detail if need be, using a 2D derivation of the item. So we click this button, and within the top screen we choose a projection. So front projection, for example, right projection, and we have a more traditional orthographic view of the part. We can zoom in and out again if need be, and this is very useful if you wanted to take specific measurements and take a screenshot and email or send to someone else, or even take a PDF printout. And what we do here is to get the measurement tool live up above, I can right click and enter dimensioning mode, and you can see extra tools appear within this ribbon bar. So let's say I wanted to know the distance between here and here. We can horizontal measurement. And this is, you can see before I left click, you can see there are certain snap points within this item. So if I left click on this snap, left click on this snap, and drag out my dimension, left click to accept, is a little bit small, this dimension. Let's say I just want to change that, make it a little bit larger, enter to accept, and we have a 220 dimension. We know this is 220 by 220 square. We can add all sorts of dimensions here. Let's add another quick one maybe for the radius again. We have 7mm. Yeah. And this is useful for things that are not so easy to dimension within this mode. So maybe I want to know the center to center of these slots. So maybe I can grab the center line as a pick point and get that dimension. And as I say, we can then print using the print to PDF button and take a nice image for reference or sending to anyone else. Another great example of how CADENAS is used to not only model but interrogate the Sikla parts. This is one thing that is overlooked, I think, with this part data catalog, is not only to model within AutoCAD, but to just download and allow interrogation of the parts. Okay. So we can, if we go back to the characteristics tab, because we were in 2D derivation, along this item here, we're just focusing in on this item here. We have LOD, so the amount of detail we want to see within the CAD item can be reduced. Let's put this up to back to LOD 400. We have specific characteristics like the weight of the item if we need to know that, the part number, things like the slot size for the holes, the plate itself, its dimensions here, all sorts of things like that. But even more detail, this is in German, so we can add, for example, the screws to attach the beam section if need be, or even the anchors. So this is a base plate which can be fixed to concrete floors, soffits or walls. And let's say we want to see these anchors with anchors. We then have the option here to manipulate the type of anchors which we will use. And what's important is when we export this into the CAD model, these anchors will be in place and included in the bill of materials as well. This is very useful. Another great example of this is our adjustable pipe shoes. I'm just in this instance not going to use a part number in my search, just going to use the short code of the part, so the LCHV, hit return. There are a number of items with LCHV in their title, so it will return the relevant items, just like a Google search would. So, and you can see it's highlighted in the title. So what I was looking for is the LCHV, so height variable Sikla industrial pipe shoe, the 90mm height. Double click here. And you can see, because I didn't put a specific part number in, which in this instance could be any number of these items, we get the whole category. There was no filter. But let's say we want to hone in on maybe the 6-inch variation. If I were to double click, you can see that we now have a filter active. We can turn this on and off. If you want to see the whole catalogue, if you're just wondering, oh, what size do these pipe shoes go up to? We can scroll up and down. We can see the 12-inch all the way down to even smaller than DN15. Okay. Let's say we hone in on a 6-inch variation that we say, double click, and look at what options we have to manipulate. As this is an adjustable pipe shoe, maybe we want to have this inserted into our CAD model at the correct adjusted height. So let's look at the range. Off the shelf, these pipe shoes come supplied in either 90mm, 150mm or 200mm heights. As we've chosen the LCHV 90, you can see we can lower the height, the pipe center line, down to 88, or increase it up to 113. So we can use this slide if need be to change this height, but let's just manipulate this to something using the keypad. So let's say 110 and click tick to accept. Can we see that the part has already and automatically increased its height? Okay. We have other options going along this toolbar to the right. Our industrial pipe shoes are able to have the slide plate removed if we to use it with some Sikla bracketry, specifically the fixed point. Put that back on. It comes supplied with the plate. Interestingly, and to facilitate modeling, again, to speed things up, we can add some connecting parts. So what we're going to do at the moment, we just have a movable bearing or a resting pipe shoe, but we can add a guide bracket, a Sikla guide bracket to this. Or we can add a Sikla fixed point bracket. And if at the moment we have some options for the type of bracket, so we can either use it with our F80 system, the F100 system, or steel beams. So let's say we want a fixed point bracket on a traditional steel beam. Opens up another option to the right because we have 4 types of bracketry depending on the width of the traditional beam flange. So let's say we would like to land somewhere around a 180 beam. Let's choose the 161-220, and specifically we will change this to 180mm. Our clamping range has widened, and we can put this all the way up to the top if we need be, and using the slider, select, see the clamp increases. Okay, this is very useful for inserting before we get into AutoCAD because it can be more difficult to manipulate. And again, we have two parts here, the pipe shoe itself, which is part number 110070, and also the bracketry, which again comes out on the bill of materials. Okay. For this demonstration, I have an indicative Sikla secondary pipe support that has been modeled already, but I'll draw your attention to the data within this AutoCAD file. So if I to just left click on the base plate, you can see within the attributes, because this is essentially a blocked item, we have the name of the product, the part number, the details about the product itself. We have a WBD F80 120, the size of the base plate, the size of the anchors required and the clamps, and so on and so forth. And again, with the profile, A192539, at length 750, and so on and so forth. And we also have a guide bracket. So to demonstrate how we would model with this, I have an indicative Navisworks model, because how the process would generally work is the user, designer, would stick build the items in situ within AutoCAD and either create a drawing from this item. So something like this, with a bit more tidying, of course. Okay. However, it may be that a fabrication drawing is not required, and the modeling process needs to happen first. So in this instance, I have a legacy project, and within this project, I am going to append the file that we're using. So this is worth mentioning that I'm running Navisworks Manage. To do this, you need the full-fledged version of Navisworks. So it allows you to append items and manipulate lots of other things. It's a very good tool. So up in the Home tool, we will append the Sikla item for this demonstration, just saved on my desktop. So example DWG pipe support 611. Let's open this. You can see that now we have a new item within our selection tree. If we were to save this as a new Navisworks, this would be embedded within the data within the file. At the moment, this is just appended. Okay, so let's just, if you weren't aware of the shortcut, just page down on this item and we can see support now in situ. Okay, the support that we have designed already and stick built with the Sikla parts. Okay, it's worth mentioning again that the user, it is advised that the user has some existing base knowledge of the Sikla parts and their compatibility, because the user is free to model these parts as they wish, i.e. there is a potential for incorrect parts to be used together. This is not a automated tool, so please reach out for some Sikla product training on the parts before modeling with this, if there is new users to the Sikla range. So within this file, I can manipulate these items and move them around the model, for example, using these tools, so on and so forth, and rotate, for example, like this. However, this is just for viewing. This does not reflect any changes in the native file. Okay. So let's remove this item, append it again, and you can see that it will be back in exactly the same place. Okay. So let's say we want to add something to this file. Perhaps if we were to scan through and see what could be changed. Okay, so this is a U-bolt, a Sikla U-bolt attached using a docket bracket to one of our profiles. Let's say, for example, there is maybe a manhole cover around this area, and we want to extend this top crossbar to pick up these two pipelines here. Okay. So what we can do is let's check how long this part is within the model already. So I'm left clicking on the profile. Blue highlights blue when I'm selected. I can see that it's 270 mil long currently. Let's go, and the part number we will need to do this is a 192539, the Sikla F80 profile. Again, I'll take this opportunity here to say that unfortunately, as it is a block, we cannot just simply extend these parts, because this isn't possible. We'd need to unblock the item and lose a lot of its attributes that are important to be carried through to a bill of materials. So I'll take the 192539, open up the CADENAS Part Data Manager, hit return, and we see when we double click this item that we have a slice, just a slice of profile, indicative right now. So it's only 10 millimeters long. So let's say we need, well, we can potentially measure how much we need using the Navisworks tools. This would be a very similar process to what a designer may do. Let's use the measure tool to grab the end of the profile approximately to the side of the section. We need another 430, 450, 500 mil-ish. Okay. So let's go to the profile and use the edit length tool. And let's put this at 800 and tick. And you can see the example in the screen has changed length. Okay. If we wanted to, we can also add some Sikla holes. But you can see this applies greater detail within the item. And there may be use cases where this is necessary. For example, a very closely, two pipes being very close, or something similar to that. So I'd recommend leaving these profiles without holes, because the file and data will rapidly increase with a large amounts of supports being modeled. Similarly to the level of detail. Okay, so if we drop this down to 300, you can see we have an arbitrary square hollow section, which of course Sikla is not. So we want to show the wonderful characteristics of Sikla, but perhaps without the holes in this instance. Okay. So we are ready to insert this. So as I say, I'm running AutoCAD 2021. This is completely compatible with all latest and greatest updates of the AutoCAD. But when you were to first load CADENAS, you would want to insert this item as a, here, we want to add a 3D CAD format, AutoCAD format, AutoCAD 3D. Okay. As you can see, there are lots of other formats available, some neutral formats, step files, DXFs, lots of things if you want to do some 3D printing. So AutoCAD 3D DWG, and whatever you choose here will remain on this button as a toggle. So hence why I don't need to do that every time. But once I do choose that item, okay, I get a prompt pop up. So I can choose what version I'm running. Okay. This here is where a copy of this item will be made onto your machine. So this could be anywhere, and what it looks like is something like this. This is just on my documents at the moment. and essentially is a part data extract from the library with specific characteristics added. So for example, this would just be the length of this item. Okay. You can open that directory if you wish after inserting. I'm going to leave that closed, okay, or unchecked. There are some advanced settings which we won't cover now, but these may need to be manipulated in the first instance, okay? But once you're happy with the export settings, such as line weights or colors and things like that, I would suggest using the defaults out of the box to begin with. We can click OK. And once we will insert this into our open AutoCAD file, you need to have an AutoCAD file open for this to work. So let's say OK. And that copy is going to be made on my C drive. As I've already done this as one example prior, it's saying, do you want to make a copy of this? Yes, I do. Don't worry, it's just making you aware that you're replacing one of those items in your CAD directory. So yes, unless of course you want a copy. Now, AutoCAD automatically opens, and we're about to insert this block, okay? Now, we have a few variables which we can manipulate. The insertion point, unless you are modeling at global 000, which may be what you want to do in the very first instance, I'm going to leave this check so I can specify where to place my beam section. Scale, I'm going to leave this as 1:1 in all three axes, X, Y, and Z, which is a good idea. We want everything to be uniform and aligned with the units of measure within the properties of your file. Rotation, I will leave checked because I maybe will need to manipulate the item if when I insert it. This could be useful for, say, cantilevers or other items which you may need to manipulate without an additional command. Okay, so I'm going to click OK. Okay, so I have now on the end of my mouse the 800 long, which we can see down here, beam section, F80 beam section. And just in this instance, I'm going to model in wireframe isometric mode, right click with shift held just to pick up the midpoint of this beam section. Okay, and this is because I left rotation free, I can, if need be, stand it upright or rotate, which can be useful. If that was left unchecked, it would just default to horizontal. Okay, I want to leave that as it is and left click to accept the rotation. And then I have the item in my 3D file. Now we can see if I look in a front view that because I picked the top midpoint of the profile, I may need to manipulate this a little bit. So I'm going to just use the standard AutoCAD tools. That's a left click crossing box. Of course, we can do right click as well and all sorts of things like that, but left click and then M move. I'm just going to move this down half the profile width so I am aligned. Okay. Now, I actually want this beam section to be moved over this way. So whilst you're in this isn't a lesson in AutoCAD, but let's just see how far I need to move this along. So we can see 527, let's say we need to shift this left or west, 527. Okay, and then look again in south east isometric, because if it wasn't obvious, this item is relevant to the coordinate system you're modeling in. Okay, and as it happens, within the CAD file, my plant file, my Navisworks, is very convenient because it isn't always convenient that my plant north is indeed aligned square. So it's not out of rotation, which can cause a pain because in the first instance of modeling, if we want to see everything geospatially correct, i.e. not at coordinate system 000, but local to the site datum, And we can see how far away this is, for example, by using a measure tool. Measure. If I just pick somewhere on this base plate in the first instance, let's say I want to pick, let's pick somewhere here. If I can do that, let's do that. Oh, excuse me. I have to actually click measure first. Okay, we can see that we're almost at zero elevation, 45 meters north and 10 meters west of the local of the data site datum. So why am I bringing that up? So what I would like you to remember is that if you insert your CAD file and you can't see it, it's probably at 0.000 unless you have moved it already. Okay, so let's say I can move this item within my CAD file relative. Okay, well, let's first of all, because I have added the extension in this member, I want to make sure to save the file. Okay, open up my Navisworks. In the home bar, we want to hit refresh. Okay, it's also pinned to the quick access toolbar, but let's hit refresh and we should see the extension of what we've modeled. Okay, it looks like 800 was a good guess to pick up those pipes. Of course, we'd need maybe U-bolts or something like that, but that is one way to manipulate the CAD file. And like I said, if I want to see this move in situ and actually update the native file, I can move this whole file. Let's say move this 500. Make sure your ortho lock is on. 500. Hit save. Back to Navisworks and refresh, and our file has moved, for example. Okay. Easy peasy for this specific item. And unfortunately, like I said already, there is not a way to stretch or manipulate the profiles, but you can easily delete and remodel is the way I'd suggest. One thing I was going to just quickly explain is when you explode the item, or expand the item, should I say, in the selection tree, it is a mimic of the Sikla items that we have modeled. So 192539 at length 750, this beam section. If we looked at the crossbar, 800 mil, 192539. Example, if you need your part numbers. And once we saved this into the master file, then it would be part of the NWD itself. At the moment, it's just referenced or appended. Okay. A useful thing, a very useful thing, a time-saving item that I would suggest is within Part Data Manager, we have a Bill of Materials button. Okay. So what I will do is click this button, Bill of Materials. Stuck last is Bill of Materials or parts list in German. Make sure you have your file active. Okay. Click this item, left click. There's not too much feedback at this point, but know that when you re-enter AutoCAD, we have select objects has become available. So I'm going to left click, right click to create a crossing box to select everything, and right click to accept. Okay. And then what we have in our open Navisworks file, Excel file, is a automatic parts list. And this can be run on more than one item, 50, 60, 70 items. You just may need a bit of time for it to process. And of course, you can manipulate this Excel file as you wish for RFQs or fabrication or something like that. So we have able to do what we need to this list. We have all the items that we have seen in the single AutoCAD file. The part numbers, the descriptions, the short code, any relevant cut lengths, because of course not all parts need to be cut here, the weight per item, and the pieces, the number of. And that is in fact how we have run the bill of materials on this example file here. It's just an export into here, an OLE file. Okay. And the last thing that is worth mentioning is, yes, this is a download from the Sikla website, but we also have a mirrored version of this on the 3dfindit.com website, which is used for lots of other OEMs and manufacturers. So if I was to search Sikla or a specific part number, it's up to you. We have the catalogue available, and there are very similar options within this online tool. The caveat is that you need to create an account. It's free, and just have your email address and create a password, and then you can manipulate the items in a very similar way to what we have just shown. And then of course choose to download these items as you wish. Okay, I think there is a limit to 50 downloads available per day, which is pretty good going, to be honest. And there's, as I say, lots of items available there. If you are perhaps you just want 1 or 2 items. If you're using the Sikla items daily and on a large scale project, I would definitely recommend using the offline and full download of CADENAS. If you are running it online, this here, I would suggest every now and again use the extras toolbar to update your catalogue. We do update some parts from time to time. We're constantly innovating. So we would go to, you can see we're online at the moment, catalogue update, and we would fetch any catalogue data that maybe needed to be updated. Okay. And then we get to choose whether we want to keep the old version or just the relevant new version. And then we can download and install any of these new parts. Okay. Excellent. That is, in fact, everything that I wanted to show you in this session. Please know that we also have other tutorial videos on the Sikla UK Oceania YouTube channel, which we will be adding to imminently. For example, our AutoCAD Plant 3D plugin. And please check back here for any videos. And yeah, thank you very much for listening. If you have any questions, please reach out.